Hello students, welcome to Sankalp. I am your Aishwarya, and today we are going to have the on electrochemistry. So electrochemistry and what are the applications of electrochemistry? Very important. Why we need to study electrochemistry is what we are going to discuss now. Okay. Fine. So electrochemistry ಬಗ್ಗೆ ಯಾಕೆ ಸ್ಟಡಿ ಮಾಡಬೇಕು? What do we mean by electrochemistry? What are its applications? Laws ಬರುತ್ತೆ ಇಲ್ಲಿ. Things we are going to cover in this chapter. Okay, basically the word electrochemistry you can see here, electro and chemistry. So we have two terms here. Electro stands for what? Electro stands for something regarding electricity. How the and chemistry stands for chemical reaction. So what is this electrochemistry? Electrochemistry is the study of electricity. It is the study of electricity and how it relates to the chemical reaction. In this entire chapter, we are going to see two things. Now, very ಎರಡು things ಬಗ್ಗೆ ಮಾತಾಡ್ತೀವಿ. What are those two things? The two things is, one is how using chemical energy, we are going to produce electricity ಅನ್ಬೋದು. We are going to generate electricity. And second, how applying electric energy, we are going to bring about a chemical reaction. That's it. These two things we are going to discuss here. ಏನಪ್ಪಾ? The first students, welcome. I am and we have the first session of electrochemistry. So what are we going to study in electrochemistry? Something related to the definition, electrochemistry. And something regarding something about chemistry. What is chemistry now? Chemical reactions ಬಗ್ಗೆ ಮಾತಾಡ್ತೀನಿ. ಅಂದ್ರೆ something the relative term between electricity and chemistry we have to talk about in this chapter, and the applications and the question why we need to study electrochemistry. All these things we'll be discussing here. So in this entire chapter we will be discussing only two things. What are those? The first thing is how using a chemical reaction we are going to generate electricity. ಹೇಗೆ electricity na produce ಮಾಡಬಹುದು. So chemical energy getting converted into electrical energy. And the second thing what we are going to say is how using electrical energy, we are going to bring about a chemical reaction. We are going to bring about chemical reaction. These are the two things what we are going to concentrate on in this entire chapter. Now this big vast chapter, only the concentration is only these two things. Okay, so what is the basis of these changes going on to occur? Yes, what is the basics? The basics about these two changes is our redox reactions. Now please don't ask me what is redox reactions, because redox reactions ಬಗ್ಗೆ ನೀವು already ನಿಮ್ಮ lower class ನಿಮ್ಮದು class 11 ಅಲ್ಲಿ ಕಲ್ತಿದ್ದೀರಿ. You can have a look there. So redox reactions ಬಗ್ಗೆ. Now see, when I say the chemical energy is going to convert into, it is going to generate electrical energy using a chemical reaction. I am going to generate electricity annaga what type of chemical reaction, ಯಾವ reaction ತನ್ನಕ್ ತಾನೇ ಆಗುತ್ತೆ, such reactions we can use to generate electricity, ಹೌದೇನಲ್ವಾ? So what type of reactions we are talking about here? We are talking about spontaneous chemical reactions. We are talking about what type of reactions? We are talking about spontaneous chemical reactions. Okay, fine. On the other hand, when I say that electrical energy is going to be used to form, to bring about a certain chemical reaction, andre a reaction tanna aagta illa. So I am going to apply some external forces, something like when I say spontaneous chemical reaction andaga, you can consider an example of a self-motivated child. Like for example, ಸ್ವಯಂ ಪ್ರೇರಿತ ಮಗು ತನ್ನಿಂದ ತಾನೇ ಸ್ಟಡಿ ಮಾಡುತ್ತೆ. Yes, you need not worry about, you need not put an external pressure that you need not say, if you don't study, I will hit you with this and that. You need not say, if you don't study, I will not take you out. I'll not bring chocolates for you. So these all things are not needed for that self-motivated child. So that child on his own will do his studies. Correct or no? But when I speak about certain cases where you have to put a pressure on that child, if some naughty child you consider, naughty child ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, ನೀವು ಬೇರೆ 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 ಆಸೆಗಳನ್ನು ತೋರಿಸಬೇಕಾಗುತ್ತೆ, ಆರ್ ಬೈ ಸ್ಟ್ರಿಕ್ಟ್ನೆಸ್ ಯು ಹ್ಯಾವ್ ಟು ಬ್ರಿಂಗ್ ದಟ್ ಚೈಲ್ಡ್ ಟು ಸ್ಟಡಿ. ನೀವು ಹೇಳಬೇಕಾಗುತ್ತೆ, ಸಿ ನೀವು ಓದ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಯು ವಿಲ್ ನಾಟ್ ಗೆಟ್ ಗುಡ್ ಮಾರ್ಕ್ಸ್ ಇನ್ ಯರ್ ಎಕ್ಸಾಮ್, ಇಫ್ ಯು ನಾಟ್ ಸ್ಟಡಿ ಐ ವಿಲ್ ಹಿಟ್ ಯು, ಇಫ್ ಯು ನಾಟ್ ಸ್ಟಡಿ ಐ ವಿಲ್ ನಾಟ್ ಬ್ರಿಂಗ್ ಯು ಚಾಕ್ಲೇಟ್ಸ್ ಅಂತ ಎಲ್ಲ ಹೇಳಬೇಕಾಗುತ್ತೆ. ಎಸ್ ಆರ್ ನೋ? ಸೇಮ್ ಥಿಂಗ್ ಅಪ್ಲೈ ಹಿಯರ್. ಸ್ಪಾಂಟೇನಿಯಸ್ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ಸ್ ಅಂದ್ರೆ ಏನು? ಸೆಲ್ಫ್ ಮೋಟಿವೇಟೆಡ್ ಚೈಲ್ಡ್ ತರ, they will occur on their own. What are spontaneous chemical reactions? The reactions which occur on their own. On their own. In essence, what do I mean? Capable to proceed in a given direction with no external energy being needed. So I can write here. So spontaneous reactions anta andrenu, they are capable to proceed. They are capable to proceed in a particular direction. In a particular direction with no external energy ಅಥವಾ no external support and no external energy being needed. ಅದಕ್ಕೆ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, being needed. So it will proceed on its own. You need not put any external energy. It occurs on its own, spontaneously ಆಗುತ್ತೆ. Here on the other hand, what I'm talking about here, electrical energy na use ಮಾಡ್ಬಿಟ್ಟು you are going to bring about a chemical reaction. ಅಂದ್ರೆ it will not proceed on its own. So it will require certain energy to proceed. What energy you are giving? You are giving energy in the form of electricity. So such reactions are called what? They are called non-spontaneous reactions. ಹೌದೇನಲ್ಲ? They are called non-spontaneous chemical reactions. Non-spontaneous chemical reactions. So they do not occur on their own. They to proceed in a particular direction, they need an external help. They need, like your example of naughty child. So we talk about non-spontaneous reactions. When using electrical energy, we are going to make a reaction happen. We are going to make a chemical reaction happen, which is not going to proceed on its own. So using electricity, we give extra push so that the reaction can occur. So this is about non-spontaneous chemical reactions. Now the question arises, okay, chemical energy in the, you are going to produce electricity, fine. Electrical energy use ಮಾಡ್ಕೊಂಡು you are going to bring about a reaction which is not going to happen. Okay, but why we need to do that? Electrochemistry ಯಾಕೆ ಬೇಕು? Why we need to study electrochemistry? So when the question arises, We have an answer. So what is that answer? One of the application of electrochemistry, the most commonly used thing is your battery. We make use of this battery, right? So battery is one of the application of electrochemistry itself. Battery is one of the application. We'll be seeing how. So battery use ಮಾಡ್ತೀವಪ್ಪ. We use it in watches, we use it in cell phone, ನಮ್ಮ phone mobile ಅಲ್ಲಿ battery ಇದೆ. We use it in watch, clocks ಅಲ್ಲಿ use ಮಾಡ್ತೀವಿ, calculator ಅಲ್ಲಿ use ಮಾಡ್ತೀವಿ, electric car ಅಲ್ಲಿ battery ಬರುತ್ತೆ. Then even in toys, see, most my kids, my two kids, they are all the toys which are having battery in one or the other ways. So battery is use ಇದೆಯಪ್ಪ ಅಂತಂದ್ಮೇಲೆ the study of electrochemistry becomes important. The second one is, the second important application is something call it as electroplating. Electroplating, ನೀವು ಕೇಳಿರ್ಬೋದು. You might have seen something like gold plated ornaments use ಮಾಡಿರ್ಬೋದು, gold plated. ನೋಡಿದಿರಿ. Then you have certain plates used for offering puja and all, which are silver plated. They are not made up of silver, but the coating is just of silver. Yes or no? Silver plated. Then chrome plated handles, ನಾವು door handles, bathroom handles ಎಲ್ಲ ನೋಡ್ತೀವಿ. Those are chrome plated ಅಂತಾರೆ. Is that made up of chromium? Actually no, it is just a layer which is being covered on the particular metal. Iron use ಮಾಡಿರಬಹುದು. Yes, chrome plated. So what is done here in all these cases, one of the metal, here a layer of one of the metal, on one metal a layer of one of the metal is being plated using what? Using electricity actually. So that is called electroplating. This is also an important application of our electrochemistry. So here, that's the reason we are going to talk about electrochemistry in detail. So electrochemistry andaga, what is the bottom line of electrochemistry? Heli nodana. The bottom line of electrochemistry is our chemical, it is our redox reactions. The bottom line, it is redox reactions. And I hope you know what are redox reactions, where reduction, oxidation, they occur simultaneously. The bottom line of redox reactions ಏನಪ್ಪಾ? The bottom line of redox reaction says that everyone wants to be stable. Everyone wants to be stable. Yes, everyone wants to be stable. ಹೊಸವಾಗಿ ಯಾವುದೋ ಒಂದು ಪ್ಲೇಸಿಗೆ ಹೋಗ್ತೀವಿ, we are very curious about knowing that concept. So now we'll be very unstable there, and we talk to some people, communication ಮಾಡ್ತೀವಿ, we become stable there. Yes, same thing. Rich people become stable by donating some amount or something, some clothing, so some food to the poor people. Yes or no? Similarly, here when we talk about redox reactions, what is the bottom line? ಇಷ್ಟ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. Every compound, every atom, every element, everyone wants to be stable. So this is the thing what we are going to study in detail. So if I take an example, like as I told, the rich people, they want to be stable. What they do, they donate the amount, some money to poor. So rich people ದುಡ್ಡನ್ನ ಕೊಟ್ಬಿಟ್ಟು ಸ್ಟೇಬಲ್ ಆಗ್ತಾರೆ, poor people ದುಡ್ಡನ್ನ ತಗೊಂಡ್ಬಿಟ್ಟು ಸ್ಟೇಬಲ್ ಆಗ್ತಾರೆ. Yes or no? Similarly, here when I talk about some of the elements ಬಗ್ಗೆ ಮಾತಾಡ್ತಿರ್ಬೇಕಾದ್ರೆ, so let me consider an example, like say I have zinc. When a reaction of zinc with I have taken, let me say I have a beaker. In this I have copper sulfate solution, aqueous solution of copper sulfate. I put a rod of zinc. So the reaction proceeds. So what actually happens here? So zinc reacts with solid, you have taken it in solid form. Copper sulfate ali yava anside, there is Cu+2. So this is in aqueous condition. I'll write it like this. So what happens here is, if you observe the reaction, let's not go to the chemical form now. See, in reaction and carefully observe ಮಾಡಿದಾಗ, copper sulfate solution, it is in intense blue color. ಹೇಗಿದೆ copper sulfate solution? It is intense blue color. But when you put the zinc rod into it, after some time, andre, how the reaction proceeds? As the reaction proceeds, you will observe that the intense blue color changes to light blue. Slowly, intensity of the color goes on decreasing, and you can see some things getting deposited on zinc. So reaction agide antartha. How do you say a chemical reaction has occurred? You will see change in the color, formation of some compounds, yes or no? But here we are seeing the change in color. Now, why is that change in color? Let us see. So zinc, what it does, zinc donates electrons. Zinc donates electrons and becomes +2. So it will donate 2 electrons and becomes +2. Okay. So what type of reaction is this? This is loss of electrons. So loss of electrons ಈಗ ನಾವೇನಂತೀವಿ? Loss of electrons andre it is giving electrons, yes or no? It is oxidation, right? Fine. Then so Zn +2 ಆಗುತ್ತೆ. This Cu+2 copper sulfate solution alli copper hegide, it is in the form of +2. It will gain those 2 electrons. Adu 2 electrons na gain madbittu it will become copper, solid copper agutte. So zinc will form, it will come into solution, and copper solid form alli it goes on depositing on this zinc rod. Adike reddish deposition na ನಾವು ನೋಡಬಹುದು. So here what is happening? Here there is gain of electrons. So gain of electrons we call it as reduction. Getting? So you can see in a single reaction, both oxidation and reduction are taking place simultaneously. Idakku navenantivi redox reactions antivi, correct? So this is oxidation part and this is reduction part. Are you getting? So both are taking simultaneously. Therefore, I call it as a redox reaction. Something like a rich person, zinc is a rich person. He is rich of electrons. So what is zinc doing? It is giving its electrons to become stable. Zn+2 state bandaga zinc becomes stable. And how zinc becomes stable in +2 state, I need not explain it because D and F block elements we have seen that. Then copper, again in D and F block we have seen copper only copper sulfate only, it is in the form of Cu+2. Cu+2 state it is not stable. Therefore, it will gain 2 electrons. 2 electrons and again madbittu it will become Cu and it becomes stable. So everyone wants to be stable here. So this is how it happens. But when I consider another example, let me take one more example here. If I take copper plus Ag, AgNO3 solution ಅಲ್ಲಿ ತಗೊಂಡಿನಿ ಅನ್ಕೊಳ್ಳೋಣ. So AgNO3 solution ಅಲ್ಲಿ Ag is in the form of Ag+. So what does copper do now here? Copper will donate its electrons and become Cu+2, and Cu+2 under 2 electrons it has donated. So copper has lost 2 electrons. So it is oxidation. And Ag, what it will do? It will take those 2 electrons. Since Ag is in plus state, Ag in madate, it will take only 1 electron. Therefore, I'll write 2 Ag plus ions because there are 2 electrons for balancing purpose. And it is gaining the electrons. So this is an example for reduction. Correct. Now you will have a question like, teacher, in the previous example, you just said zinc is rich and copper is poor. Howda? And here, if you see, copper is donating electrons. Here, copper was accepting the electrons. It was taking the electrons, and here, copper is donating. It's something like you just consider between illi nanu rich poor ಬಗ್ಗೆ ಹೇಳಿದೆ. Let us say there is a rich man, there is middle class man, and there is a poor man. So when I talk about rich and poor, this person is rich and this is poor, right? But when suppose let me talk about these two people. So the rich irodrinda he will give the money to this middle class person. But when I talk about a middle class person and a poor person, who is rich here now? This middle class person becomes rich, yes or no? And this is poor. So this is a relative term. This is a relative term. So to explain this relative term, relativity of the, come back to our concepts, chemistry concepts ಬಗ್ಗೆ ಮಾತಾಡೋಣ. When we talk about metals, ಅದರದ್ದು relative reactivity ಬಗ್ಗೆ ಮಾತಾಡ್ತಿರ್ಬೇಕಾದ್ರೆ, relative activity ಬಗ್ಗೆ ಮಾತಾಡ್ತಿರ್ಬೇಕಾದ್ರೆ, we have something called activity series ಅಥವಾ ಅದಕ್ಕೆ ನಾವು reactivity series ಅನ್ಬೋದು. So using this reactivity series or activity series, you can say who is actually poor and who is rich. Andre, who is having more electrons, who can donate electrons, and who can receive electrons. Yenappa idu reactivity series. So reactivity series is something like this. You have used this in most of the cases. Use ಮಾಡಿದೀವಿ. You should be knowing this. So reactivity series ಅಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ? At the top, you have potassium, sodium, I'll write the series, then you have calcium, then you have lithium, then you have magnesium, then we have aluminium, zinc, then iron, then lead, then I have hydrogen, copper, silver, and gold. And this reactivity series goes in this format. Please see here. It is in this order. Yenappa, what does this arrow mark indicate? This arrow mark indicates that It indicates that the elements which are at the top of the series, they are most reactive. The elements at the top of the series are most reactive, and the elements which come at the bottom, and as you move from top to bottom, the reactivity goes on decreasing. The reactivity goes on decreasing. So elements at the bottom of the series are least reactive and they are least reactive. Fine. So using this, you can say who is more reactive. So now first case we used zinc and copper. Correct. So zinc is more reactive. So zinc in it will donate electrons, and copper will take electrons. And the zinc is very rich, so it will give money, and copper is poor, it will take it. Similarly, when we were talking about copper and silver, see who is more rich now? Copper is more rich compared to silver. Therefore, copper will give electrons. More reactive copper donates electrons, loses electrons, and silver being less reactive, it will accept electrons. So this is what we saw in these two cases. So this is about the metal reactivity series. ಏನು ಹೇಳುತ್ತಪ್ಪ metal reactivity series? Metal reactivity series tells us it is what? It gives us a sequence. It gives us a sequence ಕೊಡುತ್ತೆ. ಎದ್ರ ಬಗ್ಗೆ sequence ಕೊಡುತ್ತೆ? It gives us a sequence of reactivity of the metals. Of reactivity. Howda? So it gives a sequence. So using this series, we can come to the conclusion that which electron can donate electrons and which electron will receive electrons. Is that clear? So as I said, if you look at this particular example, a zinc rod being immersed in copper sulfate solution, zinc rod na ನೀವು copper sulfate solution ಅಲ್ಲಿ immerse ಮಾಡಿದ್ರೆ, zinc will lose electrons and form Zn+2. Oxidation part ಆಗುತ್ತೆ. As the reaction proceeds, blue color goes on fading. It goes on becoming less intense. ಅದರ intensity ಏನಾಗುತ್ತೆ? ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. As Cu+2 ಏನಾಗ್ತಾ ಇದೆ? Cu+2 is getting converted to copper, which is depositing on the zinc rod, which is getting deposited on the zinc rod. And where is this Zn+2? It is coming into the solution. Solution alli Zn+2 ions bartide. Is that clear? Vice versa if I take the reaction. Now, let us talk about the vice versa. Andre, what I'm going to do is I'm going to take a beaker which is containing ZnSO4 solution. ZnSO4 solution is there. And I'm going to dip a rod of copper. Now you tell me, will the reaction occur? Teacher, copper will react. Okay, let us say copper is being in solid form and in ZnSO4, that is Zn+2 in aqueous form. So reaction will occur. Copper will lose electrons. It will form Cu+2 and zinc+2 will take those 2 electrons and form Zn. Is that possible? Not possible. Can poor person donate his money to rich person? It is not possible. It is not possible. So if you look at the reactivity series, copper being less reactive than zinc, it will not donate any electrons. So I'll say, will the solution change? Will there be any reaction? Not, of course. So there will be no reaction taking place. Getting? So there will not take any reaction. So here, further, ಇಲ್ಲಿ ನಮಗೆ ಬೇಕಾಗಿರೋ ಕೆಲವೊಂದು ಟರ್ಮ್ಸ್ ನ ಮೆಮರಿ ಟಿಪ್ ಮಾಡ್ಕೊಂಡು ಬಿಡೋಣ. ಸೊ ವಾಟ್ ಇಸ್ ದಟ್? ಆಕ್ಸಿಡೇಷನ್ ರಿಡಕ್ಷನ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಿರ್ಬೇಕಾದ್ರೆ ವಿ ವಿಲ್ ಬಿ ಮೇಕಿಂಗ್ ಯೂಸ್ ಆಫ್ ಸರ್ಟನ್ ಟರ್ಮ್ಸ್ ಕಾಲ್ಡ್ electrodes ಬಗ್ಗೆ ಮಾತಾಡ್ತೀವಿ. ಸೊ ವಾಟ್ ಆರ್ these electrodes? Electrodes ಅಂದ್ರೆ ಏನು? They are metal rods, nothing much. Electrodes are metal rods which will help in the flow of electricity ashte. And these electrodes are of two types. You have anode and you have cathode. Now the students come to the confusion. Illi confusion arise agutte. How to remember anode or cathode? Because ನೀವು redox reactions ಬಗ್ಗೆ ಕಲ್ತಿದ್ದೀರಿ. Oxidation ಎಲ್ಲಾಗುತ್ತೆ? cathode ಹತ್ರ ಆಗುತ್ತಾ? anode ಹತ್ರ ಆಗುತ್ತಾ? Reduction ಎಲ್ಲಾಗುತ್ತೆ? Whether it occurs at anode or cathode. Anode ಅಂದ್ರೆ positive, cathode ಅಂದ್ರೆ negative. So many questions arise. Okay. So here I have a memory tip for you. What is the memory tip? Please remember. When we talk about oxidation and reduction, where do they occur? Whether they occur at cathode, whether they occur at anode. Please remember, oxidation always occurs at anode. And anode is negatively charged electrode. Negative electrode anona. We'll see slowly namaga artha agutte yaka negative antivi anta. I'll just make the conclusion there also when I'll be explaining. You need not worry about that. And reduction ellagutte, it always happens at cathode, which is a positive electrode on both. Okay. Now, how to remember this? Here I have a memory tip to remember. So you can remember it as an ox and a red cat. Most of the, in books also, this memory tip is being given nowadays. So you can remember it like this: anox, anode oxidation, anox, anode oxidation. Correct? Red cat, reduction takes place at cathode. So this is a memory tip. So you can use it to remember how at what anode hatra ಏನಾಗುತ್ತೆ, cathode hatra ಏನಾಗುತ್ತೆ. And one more thing, reduction andre ಏನು? Reduction ಅಂತ ಅಂದ್ರೆ gain of electrons. And oxidation andre loss of electrons. ಇದಕ್ಕೂ ಒಂದು memory tip ಇದೆ. Shall I tell you? This was the memory tip which was told by my teacher. Yeah. Oxidation, OIL REG. This is the memory tip. OIL, oxidation is loss of electrons, reduction is gain of electrons. Oxidation is loss of electrons, reduction is gain of electrons. Oxidation ellagate? Anox. Oxidation occurs at anode. Reduction ellagate? Red cat, at cathode. Reduction occurs at cathode. So using such redox reactions, oxidation reduction simultaneously ಆಗ್ತಿದೆ. Using such redox reactions, we are going to generate electricity. So using such redox chemical reactions, to be more specific, using such redox chemical reactions which are spontaneous, we are going to generate electricity. We are going to generate electrical energy. We are going to generate electrical energy. Now, who is going to do this for me? Who is going to fulfill this target for me? Who is going to do? Sumne ready chemical reaction ಮಾಡ್ಬಿಟ್ಟು, can you, where you will do the chemical reaction? Lab ಅಲ್ಲಿ ಹೇಗೆ ಮಾಡ್ತೀರಿ? So who is going to fulfill this target for me? Chemical reaction na use ಮಾಡ್ಬಿಟ್ಟು electrical energy na generate ಮಾಡ್ಲಿಕ್ಕೆ help ಮಾಡೋದು ಯಾರು? Who is going to fulfill the target? It is the electrochemical cell. It is the electrochemical cell. So here we are going to talk about the electrochemical cell. So let us see what is an electrochemical cell. So let us be specific. We'll take electrochemical cell, one electrochemical cell, that is Daniell cell. Daniell cell, we write it like this also, ZnCu cell. That means it contains zinc and copper, something regarding zinc and copper. So we are going to talk about Daniell cell. So this was designed by Daniell anta yak bantu, because this was being designed by scientist called John Daniell. So in his honor, it is being termed as Daniell cell. So hence the name. Okay. So what does this Daniell cell actually consist of? This Daniell cell consists of, so this Daniell cell, let me make it very simple. So here, we have a Daniell cell, which is also called galvanic cell. I'll come to it a bit later. So see here, you can see Daniell cell alli enen barutte. Don't get worried. Don't imagine and nodbiಟ್ಟು what is this anta confusion akobedi. So we will take one by one. Let us understand one by one. So here you can see these are the two beakers. Okay, I call them beakers. Actually, chemical term alli navenantivi, these are called half cells. We'll come to it one by one. So in this one beaker, ಮೊದಲನೇ beaker alli, I have taken zinc sulfate solution. Zinc sulfate solution is being taken, and a zinc rod is being immersed in the zinc sulfate solution. Okay, and the other beaker, I have taken copper sulfate solution, and copper rod is being immersed in copper sulfate solution. So I have two beakers. ಒಂದ್ರೊಳಗೆ zinc rod is being immersed in zinc sulfate solution, and in the other one copper rod is being immersed. ಇಷ್ಟೇ ಯೋಚನೆ ಮಾಡಿ ನೀವು. You have zinc sulfate solution, zinc sulfate solution na ತಗೊಂಡಿದ್ರಿ. I'll show it in this form. So copper sulfate solution, copper rod is being immersed in copper sulfate solution. Okay, so what happens here? Fine. So I will show it in this format. So I have one beaker and I have another beaker. So in this, I have taken zinc rod, which is being immersed in zinc sulfate solution, and here I have copper rod being immersed in copper sulfate solution. So here I do the naming. So this is my ZnSO4 solution, and this is zinc rod. and this is a CuSO4 solution. And which rod is there? Copper rod is being immersed. Okay. So zinc being more reactive, what it does, it gives electrons and becomes Zn+2, right? So zinc being more reactive, it will give electrons and form Zn+2 ion. So it will give out 2 electrons. Understanding? So let's concentrate on this part only. So zinc being more reactive will lose 2 electrons and form Zn+2 ion and ಅಲ್ಲಿ stable ಆಗುತ್ತೆ. And this Zn+2 ion from the zinc rod, it will come into the solution. So Zn+2 ions get into the solution. Already ZnSO4 ಅಲ್ಲಿ Zn+2 ions ಇದೆ, but these Zn+2 ions are coming from where? They are coming from the zinc rod. Right, fine. So leaving behind electrons. Electrons ಎಲ್ಲಿ ಉಳಿದಪ್ಪ? Electrons, they are remaining here. Rod ಮೇಲೆ electrons ಉಳಿದ್ಬಿಟ್ಟು. So electrons are remaining here. Getting my point? So Zn is losing electrons. So there is loss of electrons. So loss of electrons andre ಏನು? Loss of electrons is oxidation. So loss of electrons is oxidation. So on the rod remain electrons because zinc gives electrons and becomes Zn+2, which comes into the solution. So leaving behind the electrons on the rod. Okay, so it is undergoing oxidation. So ಇದು ಯಾವ rod ಆಯ್ತಪ್ಪ? Anox. So what rod it is? It is anode. Is that clear? So this is anode. This is my anode ಅನ್ಬೋದು. This is my anode. So what are there on anode? Electrons are there. Electrons andre ಏನು? They are negatively charged particles. Getting my point? So anode I will denote it as minus. Understood? Why negative on anode? Is that clear? Fine. Coming to the next point. So electrons are getting accumulated on the zinc rod. Yes, these electrons, they are free to move. So where they will move? So let me make a connection here. And I'll put a bulb here. I'll tell you why bulb is being taken. Okay, I'll put a bulb. I'll put a bulb here. Fine. Okay. So since these electrons are free to move, they'll move where? They will move through this connection and they will come to copper rod. Copper rod atra electrons bandbitwapa. So they will come to copper rod. Now this copper, you know, this copper, which is in the solution. Hegideppa solution ali, it is in the form of Cu+2. The Cu+2 ions which are there in the solution, see the electrons and will become happy. Okay, our electrons will become stable. So this copper ions, Cu+2 ions from the solution, very important, from the solution will take up the electrons given by zinc and they will form Cu solid part, which goes on getting deposited. Cu goes on depositing on this particular electrode. So Cu+2 is going on taking the electrons. +2 ಹೋಗ್ತಿದೆ. So what charge will get on on this electrode? So this is positive charge. So what is happening here? Cu+2, it is taking 2 electrons and becoming Cu. So there is gain of electrons. ಏನಾಗ್ತಿದೆ? There is gain of electrons. Gain of electrons ಅಂದ್ರೆ ಏನು? Gain of electrons ಅಂದ್ರೆ reduction, and that where it occurs? Red cat. Therefore, this particular electrode is called cathode. Is that clear? Up to this, you all understood. So this particular is called cathode, and Cu+2 adಕ್ಕೆ attract ಆಗ್ತಿರೋದ್ರಿಂದ we have given a positive charge for cathode. So anode negative, cathode positive. Up to this, it is clear. Up to this, so you will see that after some time, you will observe that this zinc rod is going on becoming thinner and thinner because Zn+2 ions are getting into the solution and Cu+2 ions are getting deposited on this, and therefore this rod goes on becoming thicker. So cathode goes on becoming thicker and anode goes on becoming thinner. Now our concentration goes on to the electron flow. So how is the flow of electrons here? You can see here the electron flow, it is from anode to cathode. Yes, so electron flow, it is from anode to cathode. Or to be more specific, I can say the electron flow is from zinc to copper. Anboda. So this is electron flow. Yes or no? So electron flow is there. How will be the flow of current? Flow of electron takshana current irutte. There will be electric current. So how will be the flow of current? So current flow will be in the direction opposite to flow of electrons. That is by nature, we know it in physics. Yes or no? So here electron flow is from anode to cathode. Anode to cathode, that is from zinc to copper. when there is flow of electrons, electricity will be generated. And when there is electricity generated, electric current flow agutte, it will be in the direction opposite to current flow. So current flow hegagtide, it is from cathode to anode. So current direction is from cathode to anode. And what is the evidence for it? Current flow ಆಗ್ತಿದೆ ಅನ್ನೋದಕ್ಕೆ evidence ಏನು? Teacher, electron flow ಇದೆ, flow of electrons brings about charges, electricity in the circuit, we know that. Okay, hegappa, how do you prove it? Where is the evidence? Evidence is glow of bulb. Okay, the bulb glows, yes or no? Bulb will glow and after some time it will get off. Now the question is why? Yaake bulb continuous agi glow agalla? It will glow and it will glow and it will put. Why? Now let us see the reason for it. Yaake bulb continuous agi glow agalla? Now see, as the reaction is proceeding, Zn plus 2 is increasing in the first beaker. Zn plus 2 ions ಏನಾಗ್ತಿದೆ, Zn getting converted, electrons na ಕೊಟ್ಬಿಟ್ಟು already Zn plus 2 are there in the solution. It is giving here Zn plus 2 are coming into the solution. On the other hand, ಈ ಕಡೆ ನೋಡಿದಾಗ copper sulfate solution ಅಲ್ಲಿ Cu plus 2 ions, they are going on depositing on copper rod. Therefore illi which ions are more in number? Cu plus 2 na? No, because Cu plus 2 ions already they are going on depositing on the rod. So yav ions jasti ide comparatively? SO4 minus 2. So in the first beaker adak nanu half cell antivi. Now the question is, why do we call it as half cell? Half cell yaka? Okay, they are called half cells. Yenappa half cells? This particular first one, what you are seeing, idu zinc in zinc sulfate solution, this is called oxidation half cell. And this copper in copper sulfate is called reduction half cell. Because at this particular part oxidation is occurring and at this particular part reduction is occurring. So oxidation half cell alli enagtide, Zn plus 2 ions are increasing in number. So at oxidation half cell, what is happening? Zn plus 2 ions are increasing. And at reduction half cell, what is happening? SO4 minus 2 ions are increasing. Correct? So earlier how it was? Earlier it was neutral. Same charges ittu. But since this reaction is occurring, zinc losing electrons and coming into the solution, these electron flow agi, they are coming near the copper rod. So copper Cu plus 2 ions from copper sulfate, they are taking those electrons, getting deposited. So because of this, what is happening? Zn plus 2 ions are increasing in one half cell and Cu plus 2 ions are increasing in the other half cell. So here, because of this, what is happening here? Zn plus 2 ions jasti agirodrinda, let me take this X part. What this Zn plus nave illi jasti number alli idhi, already more in number. So electrons let's not send the electrons there. So electron flow enagutte, electron flow gets restricted here. Electron flow gets restricted. So electron flow will there be any current produced? No, the current won't be produced. And how the bulb will go if there is no current produced? Getting my point? Therefore, so I need something here which will neutralize the solutions from both the parts. Understanding? So here there are more Zn plus 2 ions. Here there are more SO4 minus 2 ions. So that's something. Or the other way around, innond way olag helbekappa antandre neutralize madlikke I need something. Okay, fine. Then the other point is, you can see here the electron flow is happening here. This particular part, electron flow is like this. Electron flow continuous agirbeku, charge current use agire, the circuit has to be complete. But here you can see the circuit is only like this. Like this, it is not there. There is no completion of the circuit. right? So to complete the circuit anni athwa to neutralize the particular solutions anni, I need something which will do this work for me. And what is that something? It is the salt bridge. It is the salt bridge. So salt ಕೆಲಸ ಏನಪ್ಪ? What is this salt bridge? What is the name actually? Salt bridge ಅಂತಂದ್ರೆ bridge because it's connecting both the half cells. Oxidation half cell na connect and it is connecting reduction half cell. And what is this salt? Why salt? Because into this, it is a glass tube. You can see a U-shaped glass which is immersed in opposite direction. So here into this, you can have a salt here. You have taken an electrolyte. Say salt, NaCl ತಗೊಳ್ಬಹುದು. Here KCl is taken. And along with this KCl, there is one more point, one more thing added here. So here we add, along with KCl, we add a gel called agar-agar. We add a gel called agar-agar. So what is this? This is a gel, and why it is being added? Yak add ಮಾಡ್ತೀವಪ್ಪ ನಾವು ಇದನ್ನ? See, KCl na, it should get into the solution. KCl is in solid form. ಅದು solution ಅಲ್ಲಿ ಬರ್ಬೇಕಂತ ಹೇಳಿ we use this jelly substance. So KCl, it will dissociate into K plus and Cl minus. So K plus ions, they get attracted by oppositely charged ions, that is SO4 minus 2, and Cl minus ions get attracted by oppositely charged ions, that is Zn plus 2. Therefore, what will happen? So when they get attracted by, they will pull those excess ions. K plus will pull SO4 minus 2. Even around, the cell also gets complete. The circuit also gets completed. You can see here the circuit. It was in this direction. Here it gets completed. So circuit also gets completed. So both my problems are solved. So what is the purpose of salt bridge? The purpose of salt bridge is it maintains the electrical neutrality. Electrical neutrality is maintained. It completes the circuit. It completes the circuit. And it reduces the junction potential. So these are the functions of our bridge. Okay. So in Daniell cell, Zn acts as anode, Cu as cathode. At anode, we have seen the reaction. At cathode, we have the reaction here. Then cell reaction. Okay, we'll come to this. We'll discuss it in detail now. Okay, fine. So up to here, the points are clear. I hope up to here, everything is clear. Fine. So at the conclusion, what will happen? Circuit becomes complete. The bulb will glow. The bulb will glow continuously. That is, current flow is continuous. So current is generated continuously. That is, with one reaction, with our chemical reaction, we have generated the electric current. And what is the proof for it? The bulb is glowing continuously. Then copper electrode, it is acting as cathode, right? So it is going on becoming thicker and thicker. Copper electrode here, it is going on becoming So because of the potential difference between, there was a difference of potential between anode and cathode, and because of this potential difference there was current flow, electron flow ಆಗ್ತಾ ಇತ್ತು in from zinc to copper, and the current was flowing from copper to zinc. Now this potential difference, let me call it as E. Okay, let me call this potential difference as E. Now what I'm going to do is I'm going to put an external potential, external ಆಗಿ potential difference ಹಾಕ್ತಾ ಇದ್ದೀನಿ. This external potential difference ಹೇಗಿರುತ್ತಪ್ಪ, it will be opposite to my E. So I am going to use an external potential difference. How it will be opposite to E, opposite to the potential difference which is already developed. That means what? That means this external potential difference, this external potential, it wants the electron flow in opposite direction. Okay, earlier it was from anode to cathode. Now it wants to make it to flow from cathode to anode. Understanding? So here we have three situations. The first situation is, if the external potential, whatever I'm going to apply, if the external potential is less than the potential which is developed here into the Daniell cell, what will happen? What will happen? There will be no effect, there will be no change. The electron will be still flowing from zinc to anode. The electrons will still flow from zinc to anode, and same thing will be seen. It will not make any difference. Second condition is, external potential difference is equal to my potential difference which is already been produced here. Avaga, there will not be, see, external my potential, if both are same, what will happen? The electron flow will stop. There will be no flow of electrons. No flow of electrons. When there is no flow of electrons, there is no current. Understanding? There will be no current. This is my second condition. The third condition is, if the external potential difference applied, external potential what I'm going to apply is more than the potential which is present in the cell. If the external potential is more, what it will happen? Then what will happen? Reverse of Daniell cell will occur. ಏನಾಗುತ್ತಪ್ಪ reverse of Daniell cell ಅಂದ್ರೇನು? Earlier the electron flow ಹೇಗಿತ್ತು? Electron flow was anode. When this condition is, the electron flow will be from copper to zinc. It will be from copper to zinc. Copper is not going to give electrons that easily. You are going to forcefully make a copper give electrons, correct? So you lose electrons. Ad lose adagane copper electron flow higagatte. Yes, or you can say the electron flow will be from cathode to anode. So ಯಾವ type of condition ಬಂದ್ಬಿಡ್ತಿಲ್ಲಿ? You are forcing, applying external potential, you are making a reaction which is not going to occur on its own. You are forcing it to occur which is not going to happen. You are going to bring about a non-spontaneous chemical reaction. Howda? So this is the situation where we call it as electrolytic cell. Electrolytic cell. This electrolytic cell, we will talk about it in detail about further matadana, but here I just gave you the conditions. More situations ಬಗ್ಗೆ ಮಾತಾಡಿದೆ. There, when external force is more than the potential, external potential difference is more than the non-potential difference which is being seen here, what will happen? Electron flow will be reversed. Reversed ಹೇಗೆ? zinc to copper ಆಗ್ತಾ ಇತ್ತು, rich to poor ಆಗ್ತಾ ಇತ್ತು. Now you are making forcibly the poor person to give money to the rich one, which is not going to happen actually. Yes or no? Copper is less reactive than zinc. Copper will never give its electrons. It will never come into that easily. It will never come. So you are making it happen by putting an external potential difference. So using electrical energy, you are going to bring about a chemical reaction on its own. So that's the situation where we talk about electrolytic cell, where you are going to bring about a chemical reaction. Is that clear? So using external electrical energy, we are bringing about such chemical reaction which is non-spontaneous. Okay, that we'll discuss a bit later. Fine. So let us now concentrate on this part again. Here you can see Daniell cell is a galvanic cell in which zinc and copper are used for redox reactions to take place. Zinc is reducing agent and Cu+2 is an oxidizing agent. A reducing agent, it will give electrons. Zinc will lose electrons. Bring reduction. Therefore, copper Cu plus 2 will gain those electrons. Are you getting the point? Okay. Half is known as anode. Anode, anox, and the reduction half is known as cathode. Right? From anode to cathode in the external circuit, anode is assigned negative polarity and cathode is assigned positive polarity. Fine. Okay. So here we have seen this. Now, Daniel's cell was designed using zinc and copper. So we have to go a bit detail. Electrochemical cells only. Electrochemical cells, they are also known as galvanic cells or voltaic cells. Yes, galvanic cells nu anbodu athwa adukke voltaic cells nu anbodu. Galvanic, you had seen in the previous slide, or voltaic. Galvanic, voltaic, but from names of the scientists or honorarily, Galvani anno scientist or honorarily and Volta anno scientist honorarily, the names are being given. No, Daniel cell is an example for galvanic cell. Okay, Daniel cell is an example for galvanic cell. So Daniel cell was designed using what? It was designed using zinc and copper. Just now we see. You can use different elements. You can use different elements, couple of different elements, a combination of different elements, and you can form different types of galvanic cells. Different galvanic cells can be produced. Okay. You can produce different types of galvanic cells. Now, here we need to understand some of the important terms regarding. So let us see the important terms one by one. Okay, the first important term we are going to talk about is the redox couples. So redox couples antandri ಏನು? So what do we mean redox couples? So we saw a reaction where in Daniel cell zinc ಮತ್ತು copper ನಡುವೆ reaction ನೋಡಿದ್ವಿ. So you saw a reaction between zinc and copper. So what was there? So redox couples. So when I talk about Daniel cell, so here I have this reaction in aqueous condition. I get Zn plus 2, which comes into the solution, and Cu in the form of solid gets deposited. This reaction is C. Now, from anode, zinc is getting out. From anode, zinc is getting out, and at cathode, copper is getting deposited. Right? We know this. So, combination of two half cell reactions occurring at two half cells. So, two half reactions after which are those two halves? Zinc is losing reaction electrons, forming Zn plus 2. I am repeating them once again. So, loss of electrons, oxidation. This is occurring at anode. Anode is my negative electron, right? And this is one half reaction taking place at one half cell. Then you have copper Cu plus 2 ions from the solution taking those electrons and becoming Cu solid, which is getting deposited. So this is gain of electrons, that is reduction occurring at cathode. Cathode is assigned positives. So cathode is copper electrode and cathode is copper electrode and anode is zinc electrode. So these two half cells, with one half cell and this is another half cell. These two half cells are called redox couples. Why redox couples? Because they are happening simultaneously. Simultaneously like the reaction. Correct? The second term what we are going to talk about is standard electrode potential. Standard electrode potential. So this is another important term what we are going to speak about. Standard electrode potential. Fine. So what electrode we had? Either cathode or anode. Okay. So between the electrode and its electrolytic solution, there exists a potential. We call it as electrode potential. Andre, in the first half cell, I was having a zinc rod and ZnSO4 solution. So between this zinc rod and ZnSO4 solution, between the electrode and the electrolyte, there is some potential. I call it as what? I call it as electrode potential. I call it as electrode potential. Similarly, if I talk about copper mattu copper sulfate Cu mattu CuSO4 solution, between Cu and CuSO4 solution, there is some potential and potential difference, and I call it as electrode potential. Fine. So electrode potential and the potential developed between. So what is electrode potential? It is the potential developed. The potential developed between whom? Between the electrode, and the electrolyte. And the electrolyte anotherkinta its electrolyte andu nadide. Correct? Potential developed between the electrode and its electrolyte. So in Daniel cell, consider cathode. Consider cathode. Okay. So that is cathode andre yav baratapa? Copper rod. Is that right? So when I speak about cathode, it is copper rod. So yen aagta ide copper ions, Cu plus 2 ions from CuSO4 solution. Cu plus 2 ions from CuSO4 solution, they are getting deposited on my copper rod. Is that right? So these Cu plus 2 ions from CuSO4 solution surrounding the rod, as soon as they get electrons, as soon as the electrons, they will take those electrons and they form Cu, which is getting deposited on copper, right? So Cu plus 2 deposit ಆಗ್ತಿದೆ. Positive charge is getting deposited on the cathode rod, on the rod, correct? Therefore, we can say cathode rod has positive potential. Cathode rod has what? Positive potential with respect to the electrolyte. Is that right? Is that point clear? With respect to the electrolyte. Come back to zinc rod. Now let's talk about anode. Anode hatra enidepa? Anode, there is zinc rod. Zn rod. So zinc rod, if you see here, yenagtide? Zinc is losing electrons. Zinc is losing electrons. Zinc electron Zn plus 2 ions. Zinc it is losing electrons and it is forming Zn plus 2 ions. And where are those electrons? Those electrons are present on the rod. So can I say now those plus 2 ions are coming into solution, but electrons they are on the rod. So I can say anode rod athwa zinc rod has what? It is having negative potential. It is having negative potential with respect to the electrolyte, correct? With respect to the electrolyte. Okay. So in the cell, cathode is at positive electrode potential. So I can say cathode is at positive electrode potential and anode is at negative electrode potential. Up to this is clear. Now, with respect to electrolyte. Positive electrode potential bantu, cathode bantu, negative electrode potential bantu, anode bantu. Now we will talk about SC, standard electrode potential. So what is the standard electrode potential? Standard electrode potential is nothing but electrode potential in standard condition. Electrode potential, standard electrode potential is nothing. It is electrode potential in all the standard conditions. So what are those standard conditions? Standard conditions. So the standard conditions we will have standard temperature, standard pressure, standard concentrations. Standard temperature. The standard temperature is 298 Kelvin. 298 Kelvin is standard temperature. Then we have standard pressure, 1 bar pressure and bodu. And then we have 1 molar concentration. 1 molar concentration. How that? So here standard conditions ali yavaga agate. So in the standard conditions, so standard electrode potential under standard conditions. So standard conditions at temperature, when temperature is 298 Kelvin, when pressure is 1 bar pressure or 1 atmosphere pressure, and concentration is 1 molar concentration, that is 1 mole per liter. So when these conditions satisfied, the electrode potential is called standard electrode potential. Fine. So standard electrode potential is the electrode potential under standard conditions. Okay. So here, standard electrode potential is being denoted. Electrode potential na ನಾವು ಹೇಗೆ denote ಮಾಡ್ತೀವಿ? Potential is being denoted by E. Yes, standard electrode. So E denotes what? Electrode potential. Electrode potential. Standard electrode potential na heng denote ಮಾಡ್ತೀವಿ? It is denoted by E naught. A naught is being taken. So this is standard electrode potential. Fine. So looking when if I want to write standard oxidation potential, how will I write? Electrode potentials are of two types. One to standard oxidation potential, ಇನ್ನೊಂದು standard reduction potential. So how will I write standard oxidation potential? E naught and the standard. So here I write sorry,